Now that we've seen how to find the inverse of the functions from the graphs and table, let's quickly go ahead and recap what a function and its inverse is. The first condition is the function has to be a one-to-one function, correct? So if I have two functions, f of x and f inverse of x, then the domain of the function f of x is automatically the range of the function f inverse. Remember, the x becomes the y and the y becomes the x. Now the range of the function becomes the domain of the inverse function. In quick recap, these are my domain and ranges, x and y, 1, 2, 3, a, b, c. This is the function, right? And this is the function from x to y. If I'm looking at the inverse function, let me take a bigger marker. And the inverse function, the y becomes the x and the x becomes the y. So if I look closely for the function f of x, what's the domain? The domain is 1, 2, 3. And the range is A, B, C. But for the f inverse of x, what's the domain? The domain is A, B, C. And the range is 1, 2, 3. So the domain of the function becomes the range of the inverse function. The range of the function becomes the domain of the inverse function. That's why they're inverse of one another. Now you might say, Miss, but how do I know if the functions are inverse of one another? This is very important. Let me move the screen here. For two functions to be inverse, or in the other way, how do I check if the functions are inverse? If I have two functions, f of x and g of x. You know what, let me just take the inverse notation. If I have two functions, f of x and f inverse, for me to check if these two functions are inverses of one another, I have to find the composition. Composition. What does that mean? I'm finding f of f inverse of x, and that should give you a plain x, and also f inverse of f of x. That means you will composite the function two ways. If you don't want to put it as f inverse, like I can also say you have to find f of g, which is equal to g of f, which is in turn equal to a big X. Now all this will make sense when we start doing the problems. So are you ready? Again, quick recap. For a function to be inverse, it has to be a one-to-one function. The domain becomes the range becomes the domain of the inverse function. For two functions to be inverse of one another, f of g should be equal to g of f, and that should be equal to a big fat X. Now let's go ahead and work the problems. Today's objective is to verify inverse function pairs algebraically, determine the domain and range, and restrict the domain of the function to make it one-to-one. Given function, find the inverse. Use the graph to find the inverse. So let's dive in here. Let's take a look at the first one. So this is my function f of x. This is my function g of x. And what are they asking me to do? They said, hey, determine whether the functions are inverse of each other. So what am I supposed to do? I am supposed to find the composition of these two. So I'm going to erase these, and I'm going to divide my page into two. And I am going to find f of g of x here. And I know that I should get an x. And I'm going to find g of f of x here. And I know that should be an x again. So we are compositing the function. Remember, the other way of writing this is f of g of x. And this is g of f of x. Now let's go ahead and do each one of them separately. So my function f of x is 6x, and my function g of x is x over 6. So the first composition is f of g of x. That means f, what is my function g of x? X over 6. Now I'm going to go ahead and plug x over 6 into the function f. What is my function f? 6. But instead of x, what do I plug in? X over 6. The 6 gets cancelled. What do I end up with? X. Check. One is checked. So if the functions are inverse of one another, when you composite them, you get your function, you get the value x. Now let's try this one. G of f of x. What is my function f of x? I have it right here, which is 6x. So g of 6x. Now what is my function gx? X over 6. But instead of x, what do I have? 6x. 6x over 6, that still gives me a x. So both of these are check and check. So if you look closely, both of them are the right values, 100%. Fair enough? All right, now let's move on to the next one. Again, if you have any questions, I want you to pause, go back. And if you're confused with compositions, you might want to brush up your composition of functions. Now let's go ahead and take a look at the next one. Determine whether 4x plus 9, the function f of x 4x plus 9, and g of x, x minus 9 over 4 are inverse of one another. Again, I'm going to go ahead and draw a line because I know I have to find f of g of x, and that should be equal to x. And I have to find g of f of x, and that should be equal to x. Now let's do it. F of, what's my function g of x? X minus 9 over 4. X minus 9, let me expand this. X minus 9 over 4. And now what's my function f of x? 4x plus 9. But what do I have instead of x? I have this whole x minus 9 over 4 thingy plus 9. So this fraction x minus 9 over 4 has been replaced with x. Now do you see that I can cancel x and x? 4 and 4. And what do I have? When I cancel the 4 and 4, I have x minus 9 plus 9. And now do you see I can cancel 9 and 9? What do I end up with? I end up with the x. So the first one is a check. Now let's try the next one. It's the same composition. Now I'm going to replace my f into g. So what is my function f of x? Where is it? It is 4x. Oops, wrong ink. It is 4x plus 9. So let's go. And g of my function f of x was 4x plus 9. Right? And what am I doing? I'm replacing this into this value here. So g, what is my function g? X minus 9 over 4. But what do I have in place of x? I have 4x plus 9. That's instead of x, minus 9 divided by 4. Now, if I look closely here, the positive 9, negative 9 cancels each other. And what am I left with? 4x over 4. What is 4x over 4? It is an x, and this is also a check. So once you get x with both the compositions, you know the functions are inverse of one another. Now let's try one last one. Again, I'm going to go ahead and draw a big line in between. What am I doing? I am finding I'm finding f of g of x, and I'm finding g of f of x. And I know both of them should give me an x value. So let me plug that in here. What is my function g of x? I'm replacing my g of x with the value, which is 2 over x plus 5. I'm putting that into the function here for f of x. Here, this is a fraction, so I want to be very careful. 2 over, instead of x, I will replace my x with all of this, right? Which is 2 over x. Let me use a different color so you can see. 2 over x plus 5 minus 5. And as you can see, the positive 5, negative 5 cancel each other. And what do I have? I have 2 over x. How do you divide fractions? You keep the first fraction, change your division to multiplication, and flip the second fraction. So one is the regular x, so you don't get confused between both the x's. This is a times. And 2 and 2 cancel. What am I left with? An x value. Now let's try the next one. I should also get an x value here, correct? What do I have? I have my function g of, what is my function here? What is my f of x? F of x is 2 over x minus 5. And now, remember, I'm going to take all of this and plug into the x value. So g is what? 2 over, instead of x, what do I have? 2 over x minus 5. The whole thing plus 5. Okay? Now, how do I do this one? There's so many fractions. I'm going to just work with this one first, this part first. How do I divide fractions? I will move it all the way here. I keep the division, now becomes multiplication, and this whole thing flips. So x minus 5 over 2. And then this plus 5 comes back, plus 5. And now do you see a 2 and 2 cancel each other? What am I left with? I'm left with x minus 5 plus 5. So let me rewrite this, x minus 5 plus 5. Plus 5 minus 5 cancel. What am I left with? X. And again, both of them do satisfy, and they are the inverse of one another. Now let's go ahead. Did I move too fast? Okay, if you want to take a look here, you might want to pause the video, reverse, make sure you write this down, and then move on to the next one. Okay, so now let's move on to the next one here. Here, what do they say? They say determine the domain and range of an inverse function. And the key here is restrict the domain of a function to make it one-to-one. So the first step is you have to see if this function is one-to-one. That's only when I can have an inverse. How do I find if a function is one-to-one? You draw a horizontal line. It's a horizontal line test. If the line touches the graph more than once, this is not a one-to-one function. Now wait a minute. They asked me to restrict the domain. So what am I going to do? This is not a one-to-one function. That means I cannot find my inverse. But they asked me to find the inverse by restricting the domain. How do I do that? So here, they just said restrict the domain. So if I can make this a one-to-one. So if you see, I'm going to start with the vertex. So this is my vertex here, right? So if I can cut this in half and I only look at this function, can you see that color? If I only look at this part, then that is a one-to-one. Or if I only look at this part, then that's a one-to-one. So my domain, so the functions that I should take is just this half of the function or this half of the function. And if I look closely, what is this? This is, let me replace this line with a thinner line so you can see. So my domain is from 2 to 8 or from here to here. So this could be my domain, or this could be my domain. So it's 2 to 8 or -4 to 2. And that's exactly what you have. So you're only taking part of the function so you can find the inverse, and the condition is it has to be a 1-to-1. Now let's go ahead and take a look at the next one. Step 1, when I draw a line, if the line touches the graph more than once, it is not horizontal line. It is not a 1-to-1 function. And I know I have to restrict the domain. So by now you should have an idea. What am I doing? I'm cutting this in half. When I cut this in half, I can either use this part of the graph or I can use this part of the graph. When I'm using the left hand side, what is my domain? My domain is from 2 to 5, right? You see that? It's 2 to 5. Or when I'm using the left hand side, the domain is, sorry, right hand side, the domain is 5 to 9. And as you can see, it is, oh, that's 8, sorry. 5 to 8. 5 to 8. The function stops at 8. So it's 5 to 8 or 2 to 5.